Here, Megan's an environmental toxicologist with the Water Quality Bureau at the DNR. Her work involves assessing risk exposure of harmful substances and developing surface water criteria for the protection of human health and aquatic life.
Okay, can you see my presentation okay?
I can.
Okay. So today I am going to talk about our water quality standards and use our development of criteria for PFOS and PFOA, which are two types of per and polyfluoral alkyl substances, which I'll get into in a moment, as sort of an example. So I'll start out by just giving you an overview of our presentation. I'm gonna just give you a summary of what water quality standards are, the three things that make up water quality standards. And then I'm going to talk about how we use water quality standards to protect Wisconsin's waters. And then, like I said, we're going to go into the development of a certain type of criteria as an example. So, what are water quality standards? So they form the basis or the foundation for many programs that are administered under the Clean Water Act. And we often call them the three-legged stool because they're made up of three distinct components that all go into what we call water quality standards. So the first is designated uses, water quality criteria, and anti-degradation. And I'll go into each of those in a little bit in some more detail. Water quality standards serve several purposes. They help us establish a goal for the quality of the water in a water body. They provide the regulatory basis for permits, and they act as a target for restoration activities. So now I'm going to go into the specifics of the three legs of the three-legged stool. The first is designated uses. They are basically a determination of how a water body is used. So whether that's by people for recreation or as a drinking water source, by the aquatic communities that live in the water, or by wildlife that rely on the water for their sustenance or habitat. And so, like I mentioned before, designated uses are the part of water quality standards that establish a goal for the water body. So we look at the water and say, how can we help this water body live its best life and attain its highest condition? How can we help it serve people and wildlife in an aquatic community best? And designated uses also help us fulfill our obligations under the Clean Water Act, which says that water quality must provide for the protection and propagation of fish, shellfish, and wildlife, and recreation in and on the water. So we use designated uses to fulfill that provision that is stated in the Clean Water Act. In Wisconsin, we have designated uses that can be broadly classified into two different types, ecosystem health and human health. Ecosystem health designated uses include fish and aquatic life designated uses and a wildlife designated use. The human health designated uses include recreation and public health and welfare. And wildlife, recreation, and public health and welfare designated uses apply to all water bodies in the state with a few exceptions. But fish and aquatic life, we have those subcategorized into different sub-designated uses depending on the aquatic community that lives within that water body. So now I'm going to go to the second leg of our three-legged stool, which is water quality criteria. So water quality criteria describe conditions within a water body that are protective of the designated use. So they can be described either or expressed either as numeric values, which are a quantitative amount of a certain pollutant that's allowable in the water, or they can be expressed as a narrative description, which is usually a statement of an unacceptable condition in a water body. And again, water quality criteria help us fulfill our obligations under the Clean Water Act, which says states shall adopt criteria for priority pollutants to protect designated uses. They also say, and we also follow, that water quality criteria must be based on sound scientific rationale. And for water bodies with multiple uses, which, as I mentioned before, most water bodies in the state have multiple designated uses, criteria will be derived to support the most sensitive use. So in Wisconsin, we have different water quality criteria that support our different designated uses. So we have our designated uses here. We have criteria down here that support each designated use. So as you can see, for each designated use, we have different ways that we assess whether or not a water body is meeting that designated use. So to make sure that it's supporting the fish and aquatic life use, we make sure that it has adequate dissolved oxygen, that pH and temperature and phosphorus are in specified ranges or at specified levels, and then we ensure that there are no harmful amount of toxic pollutants in the water body, just as an example. So now we'll move to the third leg of the three-legged stool, which is anti-degradation. And anti-degradation is basically protection for high quality water bodies. So we want to maintain the status quo. We want to ensure that if a water body has high quality, we don't want to go backwards or have any kind of degradation to that water. And this initiative helps us fulfill our obligations under the Great Lakes Initiative, which is part of the Clean Water Act, which states that states shall adopt an anti-degradation standard applicable to all waters of the Great Lakes system and identify methods for implementing such a standard. So in Wisconsin, we have two anti-degradation initiatives that I'm going to talk about now. The first is an update to our 2014, our Healthy Watersheds initiative. And right now we're doing an update to our 2014 effort, which includes some new data and some restructuring. I should mention we'll have some public input opportunities on this in the relatively near future. In the session directly before this one, there was a modeling and an assessment presentation. So if you missed that, you can watch it on YouTube whenever it gets uploaded. And then tomorrow in the 10 to 11 a.m. session, there is a statewide planning talk. So make sure to check those out if these are interesting to you, because I'm just giving a little overview here. So healthy watersheds, we rank all watersheds in the state by health, and then we seek protections for the healthiest watersheds. So these rankings of different watersheds and then the protections that we're seeking for them are incorporated into different programs that we have within the state. There's no direct impact to permittees. This is just to ensure that we have protection for water bodies that we already know are healthy. The second initiative we have for anti-degradation is our outstanding or exceptional resource waters. So these are water bodies that have exceptional water quality or biology or recreational opportunities. And they, under our administrative code, if a water body has an ORW or ERW designation, we're not allowed to have any new or increased discharges unless there's a public health need. So this is to protect these water bodies. In our recent triennial standards review, which is when we look at all of our water quality standards to see if they need to be revised or updated, revising the process for designating waters as ORWs or ERWs was ranked really highly. And so this is something we're going to be working on over the next 3 years. So now I'm going to go into how water quality standards are used to protect our waters. So we've learned about what water quality standards are. What do we do with them? The first is we use them in water body assessments. So every 2 years, we assess whether our water bodies are meeting their designated uses. If we assess that a water body is not meeting one of their designated uses because they have one or more exceedance of water quality standards, we call that water body impaired. And conversely, if a water body was previously impaired but is now meeting its water quality standards, so it's gotten better, we call that water body delisted. And water bodies with exceedances appear on our list of impaired waters, which is also called the 303D list. You may hear that. And that's not sort of like a mechanism to shame the water bodies or anything. Impaired waters are subject then to restoration actions. So we put them on that list to make sure that we know which water bodies we want to have targets for restoration. So these would be total maximum daily loads or 9K element plans, things like that, to help the water body get back to its good quality. So the next way that we use our water quality standards is in permits. We issue water quality based effluent limits, or sometimes they're called QBELs, to ensure that pollutants that are discharged to a surface water doesn't result in an exceedance of the water quality standard. And so sometimes we have limits on specific pollutants, and sometimes we have limits on the total amount of an effluent that can be making up that discharge or making up the stream or water body that it's being discharged to. And QBELs are written into permits that are issued through our WPDS program, which stands for Wisconsin Pollutant Discharge Elimination System. Permits also can contain certain monitoring requirements or something called a compliance schedule to ensure that water quality goals are met. So we're not just saying you can't discharge this amount of a pollutant and then leaving it. We also include certain requirements to make sure that that permittees are following the limits that are stated in the permit. And so I just want to give a quick example of how water quality criteria and permits sort of interact with one another. So we have a water body here that has a facility on it, and the facility is discharging an effluent downstream. Our permit limits would apply here at the discharge point, and they would be issued to protect water quality criteria in the water body itself. So if the water body is small and the discharge makes up a large portion of it, the criteria may actually, or the permit limit may actually be a little more stringent than the criteria. But if it's a really large water body where the discharge makes up a very small amount of it, there may be slightly less stringent permit limits because there's so much water that's available to dilute the discharge. So now I'm going to give a quick example of how we develop criteria for two types of PFAS. I'm going to give an intro to PFAS. This is a topic that I think a lot of people have some knowledge of, so I'm not going to go into great detail. But PFAS are a family of thousands of human-made compounds. They have really unique chemical structure, gives them useful properties in things like nonstick and protective coatings, waterproof fabrics, firefighting foams, and food packaging. So we don't want to get grease from our pizza box onto our pants. However, PFAS also are known to cause negative health effects in animals and humans, and they're really difficult to break down, which is, something that makes them useful, but also is a challenge to get rid of them. And some types of PFAS really build up in fish and animal tissue. And because they don't break down, they've been found everywhere across the world. So they don't really degrade, they just kind of travel all around. So there's two types of PFAS that we wanted to develop criteria for, which are called PFOS and PFOA. And if we go back to our sort of criteria designated uses schematic here, we see that there are 3 designated uses that are supported by criteria specifying the amount of toxic substances in the water. Looking at the available data, we determined that humans are most sensitive to PFAS compared to other animals. So we decided to focus our efforts on criteria to protect public health and welfare. And then looking at this a little further, we decided to restrict our efforts to threshold criteria, which is for substances that we don't expect to cause cancer. So we have a standard equation that we use to develop threshold criteria. It has a lot of different parameters that go into it, as you can see. But what I really want you to take away from this is that several of these parameters are specified in our administrative code. We don't, we don't derive different values of these for each pollutant that we're developing criteria for. We do, however, have 2 pollutant-specific parameters that go into developing these criteria. So the first is acceptable daily exposure, which is a measure of how toxic something is. And that was developed in conjunction with myself at DNR and toxicologists and epidemiologists from DHS. And then the bioaccumulation factor, which is a measure of how much it's like the substance is likely to build up in animals' tissue if it's present in the water body. And that was developed just using data from Wisconsin and other Great Lakes states. So we had to go out and find any toxicological data, bioaccumulation data, and input this into the criteria equation. So from the last slide, you can tell that we're proposing to develop numeric criteria as opposed to narrative criteria. And if they're promulgated, these criteria will be listed in our administrative code, chapter 105, section 8. There's a table that lists numeric values for all threshold or non-cancer criteria. We're also going to have to develop specifics related to implementation of these criteria. So for specifics related to permit limits, we'll add to Administrative Code Chapter 106. And for assessment specifics, so how many times do we have to sample? What's the duration of the sampling season, that type of thing? We will add a section or sections to our Wisconsin Consolidated Assessment and Listing Methodology, or WISCALM, which is a guidance document. So we have our rulemaking timeline here. It started in 2019 and is expected to go through 2022. Right now, we're in the process of soliciting information for our economic impact analysis and drafting our economic impact analysis, which is an assessment of how we expect people to be economically impacted by this criteria. So that's where we are with our criteria development. I know this has been kind of a whirlwind, so I have some links here for if you'd like some more information on water quality standards themselves, specifically development of criteria for PFOS and PFOA, or PFAS in Wisconsin in general. So I don't know if I have any time. This was a lot to cover, but I'd be happy to take any questions if you have any. So thanks.
All right, Megan, I'll give you one question here, then I'm going to ask both Megan and Kathy to stick around if they can till the end of Sean's. Sure. If we have a little more time there, we have a break after this, so there might be some buffer time in there to go back to some of the questions for everybody. So sure. The one question I have for you here, Megan, is can you please define the acronyms TMDL, ORW, and ERW?
Sure. So TMDL is total maximum daily load, and it is a restoration action, usually for a whole watershed, to reduce the amount of a pollutant that is entering surface water from a variety of different sources. And it involves some really complicated modeling. I'm not an expert on it, but it is basically a restoration action. ORW and ERW are outstanding or exceptional resource waters, and those are designations for our high quality water bodies that we want to provide extra protection for.
All right, thank you.
Yep.
Thank you, Megan. We're gonna